So here we are. We had a few mistakes, but we won't name names as to who miscalculated. We had a lot of good work. So in red, we see the expected values by using the row and column total product divided by the table. So now, what we're going to do is we have two options. We could go and calculate observed minus expected squared over expected for all six, or we can do this using matrices. All right, so we're going to go to our calculator, and we're going to enter these as two different matrices. So how do we do that? Let's remember, we're going to go to right under math. Whoops. Right under math, we have matrix. That brings up this menu. I want to edit a matrix. So I'm going to go to here. Now I want this to include all 1, 2, 3, 4 rows. So I hit 4 by 2. That's correct. Now I'm ready to enter in all of my observed values. So I observed a 40 and a 204, etc. So we'll pause right here while we enter in the rest of the data. So we've entered our data. Now, one thing I'll show you is that if we go to matrix, and where it says names, if I enter matrix A just into my screen and hit enter, it's going to display all the values. So that's my observed. It should match up what we have in the table. If I go back in and do matrix B, that should display all of our expected values if we hit enter. So those are the two things. And now we're ready to run the chi-squared test. So we want to go to stat, and to the right, tests. Chi-squared test. Now that's down away. It's number, some of you are saying number C. Yes, it is number C. There it is, chi-squared test. And we're going to make sure we have it in the right order. Matrix A was our observed and B was our expected. So we're going to go down and calculate this statistic now. So we get a chi-squared of 34.9 or 35 and a p-value that is small again with the degrees of freedom that we just calculated just a moment ago. So chi-squared, our statistic, 34.9 with a p-value of 1, 2, 3, 4, 5, 6, and then 1, 2, 5. You can use scientific notation if you wish, but it helps me to see it visually. So extremely unlikely that these proportions are equal. So it's to the -7, so there'd be 6 zeros, and then one more moves the decimal to the right of the 1. So this means, right, the final thing here is that this means we must reject H naught, which was the idea that all of our proportions are the same. So the proportion of success for the patch, the drug, the both, or the placebo, those are not the same. The evidence is very strong. Not all proportions are equal. And at this point, we would follow up. So we would reject H naught and we would accept this. And we would follow up to compare what the actual proportion of success was in each case. So we haven't done that, but for example, we could take the proportion of successes 40 divided by 244, 74 over 244, and we could examine those proportions to see. Let's take a moment. I'll pause while we do that. So as we finish, our this test doesn't tell us which one's more effective. It just tells us that they're different. And one kind of surprising thing is that when we look at the patch, 16% of the people on the patch were able to be successful, and 16% of the people that had the placebo were able to be successful. So it seems to suggest there is no effectiveness in using the patch. But it may warrant further study because we see those who are on this prescribed drug, 30% of them were able to be successful, so we gained 14%. And those who were on both were on even greater percentage. So it could be something about how they work together that could cause an even greater gain. So it would require more study there.